Good morning, students. Today we are going to conduct the fourth experiment in our electrical machines 1 lab, that is load test on single phase induction motor. The aim of the experiment is to conduct a load test on a single phase induction motor and to plot the performance characteristic of the motor. The main apparatus required are a voltmeter, ammeter and wattmeter and tachometer to measure the speed. Here voltmeter to measure the voltage applied across the single phase induction motor, and ammeter is used to note down the current drawn at each load condition. This is the overall circuit diagram of an experiment on load test on a single phase induction motor. So here we have a phase and neutral supply, then we have a single phase auto transformer here, then an ammeter, and wattmeter is connected here to measure power, then voltmeter connected across the input terminals of a single phase induction motor. We have two windings here, the main winding and the auxiliary winding, and we are using a starting capacitor and running capacitor. During starting, the starting capacitor comes into picture. Once the motor started running at its rated speed, then this running capacitor will come into picture and the starting capacitor will go off. This centrifugal switch what we have, it will open. Then this auxiliary winding will be bypassed and directly the supply will be applied across the main winding. So this is what the overall experiment setup we have in our laboratory. So we have a single phase induction motor here, and we have a spring balance to apply the load, and then we have a auto transformer, we have a mains here. Now let's see how exactly the connections are made to conduct this experiment. Initially we will do the series connections, starting from phase point to ammeter, then wattmeter, then L2 auxiliary winding, okay, then coming back to V is shorted to the neutral point. Okay, so here basically we have a multimeter in our laboratory where exactly we can read all the electrical parameters such as voltage, current, power factor consumed by the induction motor during any load condition. Okay, let's see how exactly the connections are made. Initially the supply should be given to the auto transformer from mains. From mains we have to connect auto transformer first, and then from auto transformer phase terminal we will directly give it to the multimeter phase terminal, again neutral to the phase terminal of a multimeter. Then the phase terminal of a multimeter should be given to the main winding. Then this auxiliary winding should be shorted to the main winding. Then these two terminals should be shorted. We don't have any connections here, so we have to short these two knobs. And then from that knob we should have a bypass wire for auxiliary winding. When the motor picks up its rated speed, then this running capacitor should come into picture. Again from we have to connect one more wire between this switch, centrifugal switch, and then from running capacitor starting capacitor should be shorted. Again that phase point should be, neutral point should be given to back to the multimeter. This is how exactly the connections are made for a single phase induction motor. Here in the manual we have given that the AC represents starting capacitor, RC represents running capacitor. This is how exactly we do the connection for a single phase induction motor. Now let's see how exactly the experiment is conducted. Hello students, today we are going to conduct a load test on single phase induction motor with a rating of 3 HP and 220 volt. That is, to conduct the load test on a single phase induction motor and to plot the performance characteristic of the motor. The overall setup is as shown in the video. The circuit diagram for conducting the load test on a single phase induction motor is as shown in the diagram. As per the diagram, we have made the connection. The single phase supply is given to auto transformer Again, by the auto transformer we have given supply to the multimeter. In the multimeter we can see the voltage, current and power, also the power factor. As we have a single phase induction motor, it is having two windings, auxiliary winding and the main winding. As we know the theory behind the single phase induction motor, it requires an auxiliary winding to start. Also we have used a centrifugal switch which will help the motor during starting, and also we have a starting capacitor and running capacitor. Here also, before starting the experiment, we should check the zero position of the auto transformer. First, the mains supply is switched on. Then gradually, by varying the auto transformer, we have to apply the rated voltage of 230 volt. As we start applying the rated voltage, motor starts rotating. The shaft of the motor is connected to brake drum. Initially we have not applied any load. Once we apply the rated voltage by seeing into the multimeter, we can note down all the no load readings. That is, in the tabular column we can note down the voltage, current supplied and input watts, power factor, the S1, S2 and the corresponding speed of the motor during no load condition. The voltage applied is 230 volt. Then the input current drawn during no load is 8.7. Then the power drawn by the motor is 0.527 kilowatt and the power factor is 0.264. All the no load readings are noted down in the tabular column. So gradually apply the load by making use of spring balance. Okay, S1, S2 will start rising. We should put the multimeter in current mode to see the current drawn by the motor after loading. As the current rating of this induction motor is 13.6, so in step we should apply the load. So now the load current drawn is 11.04 amperes. The corresponding voltage for this load is 226.6. The power drawn is 1.70 kilowatts and the power factor is 0.683. For this load we have to note down all the readings along with S1 and S2. So gradually again apply the load and we should see that current is rising as we apply the load. The current rating of the motor is 13.6. So till 13.6 we can take around 5 to 6 readings. Now again keeping the multimeter in current mode, we should reduce the load by varying S1 and S2. Again slowly by varying the auto transformer the applied voltage is reduced back to 0 and the main supply is closed. After obtaining all the readings by making use of the formulas given in the manual, the calculations are done. The torque and outputs in watts and efficiency, also the slip are calculated for a corresponding load. After calculation of torque slip, the graph will be plotted as shown in the figure. This is a nature of graph which we will be obtaining after plotting the corresponding parameters. This completes the no load test on a single phase induction motor.